Good morning, good afternoon, good evening, students. Welcome back to Mrs. Manley's Integrated Math or Advanced Honors Integrated Math class for part 2 of linear functions. And today we're going to start off by talking about how do I graph linear functions. Actually, that's not in the right place. We already did that. How do I write the equation of a graph? Okay. So last week, just to review, we did talk about how to graph linear functions. And when we did that, we talked about how we need a slope, which is connected to your x, that's your m, and then your y-intercept. Because remember, these equations are in y equals mx plus b, slope-intercept form. So remember, we always start with that y-intercept. So I plot a point at -3. Then I look at my slope, +3. Slope is rise over run. So that means 3 over 1. It goes 3 over 1. And it's positive, so we rise, run to the right. Rise, run, rise, run, rise, run, and so on. And then I use a straight edge, which I don't have for my computer, to draw the line. Okay. We also discussed how to go from standard form or arithmetic sequence form to slope-intercept form. So let me just review one of those as well. So let's review number 3 up here. So remember that we are trying to get y by itself so that it can be in the form y equals mx plus b. So the first thing that we're going to do is move the x. This is a positive x, so I'll subtract 4x on both sides. 4x minus 4 is 0, so I have negative y equals. It's supposed to be mx plus b, so x comes down first, and then I have a positive 8. Okay, right now I have negative y, which is negative 1y. So I need to divide everything by -1, which essentially will just change the signs. So it becomes y equals, instead of negative 4x, it's positive 4x. Instead of positive 8, it's going to be negative 8 now. Okay. And then previous to that, we talked about switching from an arithmetic sequence to slope-intercept form. So the way that we did that was we started by bringing down the first number in the sequence. Excuse me. Distributing. 6 times n is positive 6n. 6 times -1 is -6. Then we bring down the n and combine like terms. 3 minus 6 is -3, which is the same as saying y equals 6x minus 3. Okay. So today, we're going to add on to what we've done by reviewing how to write the equation of a graph. So again, all of this is review from 8th grade. 8th grade's main focus was on linear functions. So we want to start with writing the equation. So we always need two things to write an equation. Okay, we write in slope-intercept form, y equals mx plus b. So we need m, the slope, and we need b, the y-intercept. Okay, so what is the y-intercept? Okay, the y-intercept is your starting point. It's wherever we cross the y-axis. So if I look at my y-axis, here's where I'm crossing at +2. So my y-intercept, my b, is +2. Next, I need my slope. Remember, slope is your rise over your run. It's the same as your rate of change. It's how your graph is changing. The first thing I would do would be to look at the direction of your graph to see if it's going to be negative or positive. I can see that my line is going up and to the left. Left side is negative, so this is going to be a negative slope. And then we're going to rise over run. So we're going to start at that y-intercept we found, and we're going to rise and run to the next point. So I can go ahead and mark the next point I see on here. So I'm going to rise 2, run 1. So -2 over 1. I could have also chosen this point down here. And I could have said I rise 1, 2, 3, 1, 2, 3, 4, 5, 6 over 3, which would simplify to 2 over 1. So again, I still get -2 over 1. It doesn't matter which 2 points you use because they're going to simplify to be the same rise over run. you do want to always write your most simplified answer. So I'm going to say negative 2 over 1 or just negative 2. Then I'm just going to plug into my equation. So I'm going to have y equals, my m is negative 2, x, don't forget your x, and then my y-intercept plus 2. All right, let's look at another example. All right, so again, we're going to start by looking at the y-intercept where my line crosses the y-axis. So this time that's going to be right here between negative 2 and negative 4, which would be negative 3. Now I'm going to find the slope by rising and running. If the points that are in the middle throw you off, then pick 2 points that aren't in the middle. Okay. Now we do have to be careful on this one because we can see that this graph is counting by 2's. So each square is equal to 2. So I can rise 1 block, which is 2, over. I can run 2 blocks, which would be 2, 4. So rise 2, run 4. And notice my line is going up and to the right, which is the positive side, so it's going to be positive. So I need to simplify that 2 over 4 to 1 over 2. So my slope is 1 over 2 in this case. So y equals 1/2 x minus 3. Okay, go ahead and try this one on your own. Pause your screen, complete the example in your notebook, on your dry erase board, however you're doing this, and then unpause to see if you were correct. All right, let's go ahead and take a look and see how you did. So the equation you should have had is y equals negative 1/3 x plus 1. So we get that by first finding our y-intercept of positive 1 here. Then my slope, you can see I picked another point. I'm rising 1 and running 3, and I'm going up and to the left, which is negative, so negative 1/3. All right, match the equation with the graph. Negative 7x plus 7y equals negative 49. So this is one where you're having to put 2 of these concepts together. Okay, so you have to first change this equation to slope-intercept form, then find the graph that matches. Go ahead and pause your screen now and give it a try. All right, let's take a look and see how you did. So remember, the goal here is to get y by itself because our form is y equals mx plus b. Okay, y equals mx plus b. Remember that everything that we are looking at is linear functions. The form y equals mx plus b is how we write linear functions in slope-intercept form. All of this goes together to see different representations because we're going to be looking at representations on a graph, representations on a table, representations in an equation, representations in points. But you need to see that all of these interconnect to represent the same things. Slope and rate of change are the same thing. Y-intercept and initial value are the same thing. So let's go ahead and get this in slope-intercept form. Okay, so I need to start by getting y by itself, so I'm going to move x. It's negative 7x, so I'm going to add 7x to both sides. Negative 7x and positive 7x make 0. So now I have 7y equals, x comes down first, then my y-intercept of negative 49. Now I'm going to divide all the way across. Get y equals 7 divided by 7 is 1. So I can write 1x, or I can just say x. Negative 49 divided by 7 is negative 7. So there is my equation, y equals x minus 7. Now I just need to find the graph that matches. My recommendation is to always start with your y-intercept and then mark off any graphs that you can. So my y-intercept is negative 7. So I'm going to look at each of these graphs. So this one has a y-intercept at negative 7. This one has one at negative 7. This one's at positive 7, so we can get rid of b. And this one's at positive 7, so we can get rid of d. The next thing I would look at for process of elimination would be not my actual slope, but whether it's positive or negative. In this case, it's just y equals x, x being a positive 1x. That means that my slope needs to go up and to the right, up and to the right. So if I look, A is the only one going up and to the right. C is going up and to the left. If I double check the slope to see if I'm rising 1 over running 1, it should match up. So I'm going to take a look here, see if I can find any good points. Alright, so this one's kind of tough because it's not in the corner of a graph. But if I did rise 1, I'm at half through. So if I go up another half and then over 1, I am hitting the line. Okay? But again, in this case, if you can use process of elimination to get rid of some of your graphs and then dwindle it down, do that. Alright, here's your next one. So you have 2 multiple choice questions here. So again, go ahead and pause your screen, write down your answers, and then unpause to see how you did. So the first one says, which equation models the linear function shown in the graph? Okay, so we need to look at the graph to match the equations. All right, so first thing I'm going to do is I'm going to look at the graph itself. What type of graph is this? Is it a positive graph or is it a negative graph? It's going up and to the left, making it negative. So I need a negative slope here. So that means I can get rid of C and I can get rid of D. All right, the next thing that I could look for would be my y-intercept, but we can see that both options have a y-intercept of 2, which is my y-intercept here, so that doesn't really help me too much. So the next thing I want to look at then is my actual slope. Am I rising 3 and running 4 like in A, or am I rising 4 and running 3 like in B? So let's find another good point. Remember, good points are right in the corner of the squares here. Okay, so I'm going to draw in my slope triangle, and I'm just going to count. That's a rise of 3 and a run of 4. So my slope should be 3 over 4, or specifically negative 3 over 4, which means my answer choice is A. For the second question, which equation models the linear function shown? So we're doing the same thing. Again, I'm going up and to the left. So this is a negative slope, which gets rid of B, C, and D. For this one, I don't really have to go any further, but I'm going to just to look over it with you. So my y-intercept is 6. Okay, so that would have kept A in the running. And then I could check my slope. They already gave me some points here. I could say rise 1, 2, 3, 4. Run 1, 2, 3, 4. 4 over 4 equals 1, and it's negative slope, so it's negative 1. So negative x. Alright, so now let's look at some special cases with slope. Special cases. So we have to think back and remember that we can also have zero slope, or we can have undefined slope. Zero slope is going to be a horizontal line. Okay? Zero slope tells me that my rise is 0. Okay? So you can see here I have no rise. No rise. What's my run? My run is infinite, right? Technically, my run is to infinity. So 0 divided by anything is 0. Okay, so you need to commit that to memory. If you see a horizontal line, you need to know right away, slope equals 0. Undefined slope is going to have an infinite rise because it's going up and down. So its rise is going to be infinite, but it's going to have no run. Okay, so the run is 0. So then we have to think 5 divided by 0. We can't divide by 0. Mathematically, it's impossible to divide by 0. So we call this undefined because there's no definition of dividing by 0. So again, vertical line, undefined, horizontal line, 0. All right, we're going to go ahead and keep going, and then I'll post your exit ticket in Kidem. So our next review topic from 8th grade is how do I find rate of change from a table? Remember that rate of change and slope are the same thing. There's a lot of different things that we're discussing here. It's all review, but if it's something you're struggling with, I really hope you're taking notes in your math notebook like the kids in class are doing. So rate of change on a table. So rate of change, also known as slope, is defined in the change of y over the change in x. Change in y over change in x. Sometimes you'll see it written like this, triangle y over triangle x, because triangle means change. And there's a specific formula that we use. So to find the change in y, we say y2 minus y1 over, and then the change in x, x2 minus x1. It's always y over x. Always. We'll never do x over y. Now, I know you might be thinking, well, why do I need to use the formula if I could just look at how it's changing? Okay. In a lot of cases, you can just look at how it's changing. But in some cases, they leave out points. So it's going to be better to just pick 2 points to find the slope. And this one actually has an error on it. I'm going to fix that. That should be 12. All right, so let's go ahead and give this a try. So I'm going to pull out my highlighter here. So whenever you're finding your rate of change, you need to pick 2 points, okay? When I say 2 points, I mean an x and a y make 1 point, okay? So this right here is 1 point. Because to make a point, you need an x and a y. And if you remember, tables are just a list of points on a graph. Then I need to pick another point. It doesn't matter which one. I can pick this one all the way down here. Then we're going to label them. So my first point I chose was 0, -2. So I'm going to call this one x1 and y1. And then my second point is x2, y2. You need to be careful when you are labeling. Okay? If you call 0 x1, you have to call -2 y1. Okay? They have to stay together. And then we're just going to plug into the formula. Okay? So y2 comes first, y2, which is -8. Then I need a minus sign, and then y1, -2, over x2 is going to come next, which is 12, minus x1, which is 0. The biggest mistake I see would be in your numerator here. People are going to put just -8 minus 2, but that would be saying -8 minus a positive 2. The formula itself requires us to subtract to find the change. So if we have a negative number, we're going to have subtracting a negative. We just have to remember that subtracting a negative is adding a positive because we're doing the opposite. So I have -8 plus 2. So my integer rules tell me if my signs are different, I subtract. So 8 minus 2 is 6. And then I keep the sign of the larger number. When we say the larger number, we're talking about just looking at the numbers without the signs. So 8 is larger than 2 and it's negative. So I'm going to keep the negative. Over 12 minus 0. So I get -6/12. But I have to simplify. So -6 over 12 would become -1/2. So my slope, my rate of change, my m equals -1/2. Right? Let's go ahead and try it on the second table now. So again, y2 minus y1 over x2 minus x1. So I'm going to pick 2 points. So I'm going to choose first point and second point. 1, 2, 1, 2, and 3, 8. And then I'm going to say x1, x2, y1, y2. And again, I'm just going to plug in. So y2 is first, So my y2 is 8 minus y1 is 2 over x2 is 3 minus x1 is 1. 8 minus 2 is 6. 3 minus 1 is 2. And then again, I have to simplify. 6 divided by 2 is 3. So I can say 3 or 3 over 1. 3 or 3 over 1. Okay. What is this rate of change telling me? Okay, what is this rate of change telling me? Rate of change is telling me, again, how my y's are changing versus how my x's are changing. So a rate of change of 3 or 3 over 1 tells me that a positive 3, so my y is going up 3 and my x is going up 1. You may think, well, that's not what it shows in the table. The table shows that my y went up by 6 and my x went up by 2. Where you have to remember that we simplified here. Okay, so if we followed this pattern, we could see that there are actually more points in the table that just are not included. Because I could say 2 plus 3 is 5, and then 1 plus 1 is 2. And it would still match up, because then 5 plus 3 is 8, 2 plus 1 is 3. If my m is changing by 3, my next point would have been 11 and 4, 14 and 5, 17 and 6, 20 and 7, and so on. It's just like those arithmetic sequences. It's following a common difference. But in this case, we call it the rate of change. All right, you go ahead and do these next two tables. So go ahead and pause your screen here and answer these two tables in your notebook or on your dry erase board. And then unpause to see the answer. All right, here we go. So again, what's that equation we need to use? It's y2 minus y1 over x2 minus x1. So I'm going to go ahead and pick my points. So I'm going to choose 0, 10. Whoops. Did not choose highlighter. 0, 10, and negative 4, 6 over here. And then my other one, I'm going to choose 2, 3, and 8, 12. And it doesn't matter if you chose the same points as me, you should still get the same answer. All right, so x1, x2, y1, y2. x1, x2, y1, y2. Excuse me. And we are going to plug in. So y2, 6, minus y1, 10, over x2, negative 4 minus x1, 0. 6 minus 10, okay, different sign, so I'm going to subtract. 10 minus 6 is 4. Keep the sign a larger number. 10 is larger, so it's negative. Over negative 4 minus 0, negative 4 minus nothing is negative 4. And then I need to simplify. Negative 4 divided by negative 4 would just be 1. Okay, any number divided by itself is 1. So my slope or rate of change is 1. Remember, that means 1 over 1. 1 over 1. Sorry guys, I'm looking back at this one and thinking that that's a mistake. No, not necessarily, because I can see that my y's are going down by 2 over my x's are also going down by 2, which is going to equal 1. It's just the way that the table is written. If we were to actually plot these points, we would see that it will have a positive slope. Sorry, brain freeze. All right, and then on my second problem over here, I'm going to have y2, 12, minus y1, 3, over x2, 8, minus x1, 2. 12 minus 3 is 9. 8 minus 2 is 6. So I get m equals 9 over 6, but again, I need to simplify. Both those numbers are divisible by 3. So 3, 6, 9. 3 goes into 9 3 times. 3, 6 goes into 6 2 times. So my slope is 3 over 2. As my y's increase by 3, my x's increase by 2. All right, so you're going to answer a couple more example problems, and then we're going to go ahead and stop here for today. So which table of values does not represent a linear function? Go ahead and pause your screen to answer this question. If you don't remember how to tell if it's linear versus nonlinear, remember that in order for it to be linear, it has to have a rate of change, a constant rate of change. So the y's have to be changing by the same amount, and the x's have to be changing by the same amount. So the easiest way to look at this one would be to just check to see how each one is changing. So 7 minus 5 is 2, minus 5 is negative 3, minus 5 is negative 8. And then negative 9, 8, 7, 6 is all going down by negative 1. So that one's linear. B, 1 plus 0.5 is 1.5, plus 0.5 is 2, plus 0.5 is 2.5, and then 1, 2, 3, 4. So this one's linear. C, 7 minus 5 is 2, but 2 minus 5 is not negative 1. 2 minus 3 is negative 1, and then negative 1 minus 1 is negative 2. So I can see this one is not changing at a constant amount, so it's looking like C is the answer. Let's go ahead and double check D. So this one's going up 3, up 3, up 3, then up 1, up 1, up 1. Okay, so my answer then is C. All right, here are your next two. What linear function models the table of values? And what is the average rate of change for f of x equals 0.5 times negative 10x plus 24? So in this first example, okay, we haven't talked yet about writing the equation of a table. But a lot of times with these, you can just do it by finding the slope. So if we go ahead and find the slope here, we can say x1 and x2, y1 and y2. So y2 minus y1 over x2 minus x1. So 3 minus 5 is negative 2, and 0 minus negative 1 is positive 1. So I need a slope of negative 2. And if I look down through here, D is the only option. For the second one, we need to distribute, right? When you're distributing this, think about 0.5. 0.5 means half, so you're just taking half of whatever is in parentheses. So half of a negative 10 is going to be a negative 5. Half of a 24 is going to be a positive 12. And then specifically, we want the rate of change, which is the same as slope, which is negative 5. Answer choice B. All right, I do want you to go ahead and practice finding the rate of change on tables. Okay, practice finding the rate of change on tables. So I do want you to go ahead and pause your screen here. And then when you unpause, you'll see the answers to see how you did. Then we'll look at maybe doing a couple more or see if it's time for us to go ahead and do our exit ticket. I just want to ensure that you guys do not get too far behind my in-class students. All right, so here are your answers. Just for the sake of time, I just went ahead and used the first 2 points in each table, labeling them x1, y1, and x2, y2, and then plug them into my formula of y2 minus y1 over x2 minus x1. So for number 1, you should have gotten a slope of negative 1. For number 2, negative 3. For number 3, 1 over 2. For number 4, -1, and for number 5, 4. So when you are finding rate of change on a table, there's a few things I want you to remember. I want you to remember that rate of change on a table is showing us how our x and y values change, okay, in relation to one another. So, for example, in number 3, 1 over 2 tells us that as our y's increase by 1, our x's increase by 2. But I also want you to remember that this connects to a graph, that if in this same example, number 3, we took all those points and graphed them, 2, 2, 4, 3, 6, 4, and 8, 5, and then we picked points and we did rise over run, we would also see a rise of 1 and a run of 2, because slope and rate of change are the same thing. So we're going to go ahead and end here. Make sure that you look at your exit ticket as well as your LHS Mastery. Remember that if you're in an even class, you get your LHS Mastery on Mondays and it's due Wednesday by 3:30. If you're in an odd class, you get your LHS Mastery on Tuesdays and it's due Thursdays by 3:30. Have a great day.